Okay, algebraites, let's take a gander here. Today we are going to be multiplying or dividing rational expressions, and it turns out multiplying is dividing and dividing is multiplying because one is the inverse of the other. So let's look at the first one. Now, there are a couple different ways to approach this. Most often, when you see things like this, you're going to do something called cross-cancel, where diagonally you divide by 5 this way, and then diagonally here you divide it by 6, so I put a 4 here and a 3 here. And now we multiply straight across. So in the end we get 4 over 9 is your answer. Notice, not even any work to show down below. However, one thing that we do have to pay very close attention to is that what we've effectively done is we factored the numerators. We didn't have to show that work, but if I were to expand it out into its ugliest bigness ever, notice the 5 and the 24 I can break down to be 6 times 4, all over 3 times 6 times 3 times 5. Where's this stuff coming from? The 18 is 3 times 6. The 15 is 3 times 5. Now, why did I break it up in this fashion? Because I'm just looking for common factors to reduce. The 6's reduce, etc., like this. So you don't have to write it in expanded form. This is an expanded or a purely factored form. You don't have to expand it because most of us are already familiar with just the concept of cross-canceling, or you can cancel or reduce top and bottom as well. So anything in the numerators, as long as it's multiply, reduces with anything in the denominators. So effectively what we have done is you factored in your head and reduced things down. So this is what you've actually done. We just didn't write it like that. That's going to be more important when we get to factoring trinomials, etc. All right, so for number 2, all right, so here the 21 and the 7 both divide by 7. And good. Now the other two can divide by 12 to put a 2 here and a 3 here. And we also see if there's anything else, because sometimes there's something left over. The 3, and nothing down here reduces with those 3's. So in the end, we simply multiply across to get 9 in the numerator, 2 in the denominator, and I'm done. You don't have to show it this way, but again, the 21 is 7 times 3. The 36 is 3 times 12. The 24 is 2 times 12. And the 7 is 7 times 1. And now we start reducing things that are common, and we end up with the same answer. So factoring out and reducing.
Multiply by the reciprocal.
So looking at number 3, we can do what is called cross-canceling. I like to say reduction instead. So notice this 7 can reduce with any of the 7's down below, the 21 or the 7. But 7 is most simple, so I'll just reduce those. And then when I reduce the 6 and the 21, I divide by 3 on those ones. And then I look at the x's, and I notice that the x's, all of the x's in the numerator drop out, and one of the x's in the denominator drops out. So now I just multiply across. This one here is a 1 times a 2, so 2 is in the numerator. And then down below in the denominator, 7 times x is what's left over there. Notice the x stays down in the denominator. It's tempting to put x upstairs. So with number 4, we start reducing where we can. I notice a 7 can reduce with the 28, like so. I notice the 16 can reduce with the 4. And now I notice another reduction. Notice I have a 4 in the numerator and a 4 in the denominator. So those actually drop out or reduce as well. So I'm reducing on top of the reducing. So paying attention to that. All the a's from the denominator drop out and 2 of the a's from the numerator. All the x's from the numerator drop out and 1 of the x's from the denominator. So notice how sloppy this looks. It is very difficult to follow along what's left. So here, the only thing left here is a 1 times an a. So I write a. The only thing left down here is a 1 times an x. A over x. So that's why maybe factoring things out might be a little bit easier to see things, because when things get sloppy like this, it's difficult to follow. So let me just show you what that looks like if I were to break everything up, factor things. Notice the 16 can be 4 times 4 times x times 7 times a times a times a. Then down below is 7 times 4 times a times 4 times x. Now, why didn't I break up the 4s? The reason for that is because the top already has 4s. I didn't have to put 2 and 2 here. So the 4s drop out, the 7s drop out, pair of 2s, a pair of 2s, and lastly, a pair of x's. So this is a little bit more clear. However, it doesn't matter which method you choose, just as long as you stay organized. All right. Remember that all of math is one thing. All of math is just addition. That's it. What is subtraction then? No, subtracting is adding the opposite, is adding opposites. Well, what about multiplication? Well, multiplication is just adding a whole bunch, the same thing over and over again. And what's division? Division is just undoing adding a bunch of things over and over again. So all of math is essentially multiplication. However, so that means we can write one operation in terms of another. I can write addition or subtraction as opposites. So if I'm subtracting, I can say that's adding a negative. If I'm multiplying, I'm saying that's dividing something. Or, so pay attention to what it means to divide. Divide simply means to multiply a reciprocal. Multiply the reciprocal. And AL or OL? Reciprocal. Reciprocal. Good. It's both an A and an O. All right, there we go. Multiplying by the reciprocal. In other words, one quick way you can remember it is Kentucky Fried Chicken. KFC. Keep the first expression, flip the second one, and change from from divide to multiply. We'll get to it in a second. Change from division to multiply. So we're going to keep the first fraction, flip the second fraction, and change it to multiply. That is one way to interpret multiplying or dividing as multiplying the reciprocal. So notice this one here. I am going to keep this one, 100 over 48. I'm going to flip this one to be 8 over 10, in other words, the reciprocal. And I'm going to change to multiply. So there's my C, there's my K, and there's my F, KFC. So now there's nothing new. We did exactly this before. So now let's just start cross-reducing. So the 100 can reduce down to a 10, the 10 to a 1. The 48 reduces down to a 6, the 8 reduces to a 1. And notice the 10 and the 6 can go further. 10 over 6, and that now becomes 5 over 3. I could have done the reduction in the previous part right here, but it was just getting too sloppy, so I cleaned it up. We can apply these same ideas to anything with an x, anything with a y, any variables here. So first things first, keep the first fraction. You're going to flip the second fraction, take the reciprocal, 8x cubed, and now I'm going to change my operation. KFC, keep, flip, change. Now we use our super secret rules of reduction. We can go anything from the top to anything to the bottom. So the 4 and the 8 reduce to a 1 and a 2. The 9 and the 3 reduce to a 3 and a 1. And now the x's, I have to pay attention because they're all over the place. So it looks like all 3 x's from below and 3 x's from above. So that one's left with a 2. Now I pay attention to what's left over. I have an x squared here, an x squared here. So I have to add the exponents, not multiply. This is the one case where multiplying an exponent gives you the same. Multiplying and adding give you the same. And down below, I'm multiplying this 3 times the 2 to get a 6. And there we go. And in the next lesson, we are going to address binomials and factoring using things like GCF, or we can do difference of two squares, or snowflake.